So today we're going to be talking about evaluating trig functions of general angles. And so related to our conversation last class, I can take a look at this angle on a coordinate plane. Sorry, that should be going through 0, 0. And here, if this goes to the point -4, -6, I see that here for my x value is -4 and my y value is -6. Even though it feels uncomfortable to have negative values in a triangle because side lengths cannot be negative, here that's being used to indicate that I'm in the third quadrant, that I'm going negative for x and negative for y to give a location on the coordinate plane. So if this here represents, where did my pen go? If this here represents my theta, I can use Pythagorean theorem to find this hypotenuse, and the hypotenuse is going to be positive because here I'm taking -4 squared plus -6 squared square rooted, so I get square root of 52 or 2 root 13. So if I want to find sine of theta, here I see sine of theta is equal to opposite over hypotenuse, so I get -6 over 2 root 13, which can be simplified and rationalized to get -3 square root of 13 over 13. And cosecant is again 1 over that value, so I'm just going to flip this, what I see here, and simplify. Cosine is adjacent over hypotenuse, so -4 over 2 root 13, which can simplify to this expression. And secant is 1 over that value. So here, 2 over square root of 13 over -4, or simplified to this. And then, of course, tangent opposite over adjacent, and cotangent adjacent over opposite. Okay, so what we're seeing here is that in the coordinate plane I can always create this circle and then talk about degrees that are created on that circle and then form triangles to be able to calculate these trig values that we have. We can extend our understanding here to what we call general definitions of the trigonometric function. And I can see here that you may remember from geometry this equation of a circle centered at 0, 0. X squared plus y squared equals r squared, right? And I can just see that value here, that this is y, this is x. So x squared plus y squared equals r squared. So that gives us the general definition of our 6 trigonometric functions on the coordinate plane. So I can say that sine of theta, so if this is my theta here, it doesn't matter theta here, is equal to y, this is my y value, y divided by r, which is my hypotenuse here. Okay, and I can define each of these trig values according to that. Let me just write that in. So here I see that this guy is my y, and this is my x value. Okay, so I can just say theta is y over r, cosine x over r, tangent y over x. Okay, and then these are just the flipped of those. So what does that mean? Well, this allows us really well, anyway, I'm going to get into this in just a second in this next video. So we're going to take a look at this circle and how we can use something known as the unit circle to be able to identify key pieces of information and use that to evaluate the general angles in the unit circle. So in 13.1 we talked about SOHCAHTOA, that I could find, these constant ratios of opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, here in a right triangle, but we can very much feel like there's a lot of limitation to this. So, this theta is really limited to an angle that's between, say, 1 degree and 89 degrees. But if I want something to be, say, 90 degrees, and I want to know what is the sine of 90 degrees, I can't find that, or the sine of 127 degrees. I really am limited by this model. And so when we transfer this onto a circle, we know that I can have now positive angles, negative angles. We talked last time about coterminal angles, etc. And so here we're going to talk about the unit circle, and we kind of alluded to that last class. But a unit circle is a circle with radius 1. And we mentioned last time that, of course, in terms of our radians, that this starts at 0 and then all the way around we say is 2 pi radians, because 2 pi r is my circumference, but in a radius of 1 that's just 2 pi all the way around. So we said this is pi over 2, this is 3 pi over 2. Okay, and so I have kind of those key values. Now, I can always create a triangle here other than on these kind of quadrantial angles, or these ones that are right here on the axes. I can always create a triangle that's there. So let's see what's going on. So if I wanted to find, say, sine of this theta, I would take, and we see in our triangle, we know that this is our y and this is our x. So I would say something like sine of theta is equal to opposite over hypotenuse. So y over 1. And if I wanted to find cosine, cosine of theta is equal to x over 1. Okay, and what we see is that, of course, y divided by 1 is y, x divided by 1 is x. So here we can see that if I want to know what the cosine of theta is, I know that it's just going to be this x value. And I know that if I want to know the sine of that angle, that's just going to be sine theta. So that we're going to see that that's going to be extremely powerful. And also, as we move up, I can also then now find what would be, for instance, cosine of pi over 2 or sine of pi over 2. Okay, and as we kind of come up here, we know that, oh, that's just tied to the x value and the y value. So over here, if I start from this point here, we see that the x would be the radius and y would be 0 on the x-axis. So this is the ordered pair, 1 comma 0. So what that tells me is, if I want to say sine of 0, I get out 0 because y is 0. And if I want cosine of 0, I see cosine of 0 is 1 because I'm right here on the unit circle. Okay. Now as I move around, what we can do is we can cut or break this unit circle into all of our 30, 60, 90 and 45, 45, 90 right triangles. So if you notice here on the side, we know that our relationship here for the 30, 60, 90, and 45, 45, 90 triangles is that this side is 2x, this is x, and this is x root 3. Now, if I know that this hypotenuse is going to be 1 in the unit circle, then I know that this side is going to be half that. So this is 1/2. And so then this side is going to be x root 3. So I can say root 3 divided by 2. And the same goes here with my 45, 45, 90. We know that the relationship is x root 2. So this side is going to be, I can divide 1 divided by root 2, or if I rationalize that denominator, this becomes root 2 over 2, and the same thing for this side, root 2 over 2. Okay? So what I'm going to do is I'm going to divide up this unit circle into quarters and into sixths. And when I mean quarters, I mean the top into quarters, so really into eighths, and then the top into sixths, or really totally into 12ths. And what that's going to do is it's actually going to break up this circle into a number of these special right triangles. And I'm going to just use these properties to be able to know what the sine and cosine is for any of those angles. Okay? So if I start off here and I divide everything into quarters, if this whole thing is pi and I break it into fourths, this becomes, let me erase this, this becomes pi over 4, this becomes 2 pi over 4, or pi over 2, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and then of course 8 pi over 4. Okay, so what is pi over 4? Well, this was 180 degrees, and we know that's the same as pi. So 180 divided by 4, this corresponds with 40 degrees. Okay, sorry, whoa, try that again. 45 degrees. Okay, and if I was to create a triangle right here, what would be the ordered pair? What would be the cosine and sine associated with that angle? Well, this is a 45-45 right triangle. Okay, so we just said over here that if this hypotenuse is 1, this height is square root of 2 over 2, this base is square root of 2 over 2, so that tells me that the ordered pair is square root of 2 over 2 and square root of 2 over 2. So then if I was to ask you what is sine of pi over 4 over 45 degrees, you would just tell me that's square root of 2 over 2. Okay, so I would get that value. So I can go all the way around. So here, square root of 2 over 2. And over here I have that exact same triangle that's going to be formed, right? But here notice that my x is negative because I'm in the negative direction. So this ordered pair over here would be negative square root of 2 over 2, positive root 2 over 2. This is getting a little bit sloppy. Okay? And then down here, I see that x and y are negative. So I know that this ordered pair here, let me make myself some space. This ordered pair here is going to be negative square root of 2 over 2, comma, negative square root of 2 over 2. Okay, because x and y are negative in the triangle that I'm going to be creating there. Okay, and then moving around. Okay, moving around here, I see that I'm in the fourth quadrant now, so x is positive, y is negative if I'm right down here. So that's going to be square root of 2 over 2, negative root 2 over 2. Okay. Likewise, I can break my circle into sixths rather than just fourths. And if I do that, I'm going to break this all into 30-degree chunks. Okay, so here, when I go around, instead of 30, so that was 45, so this right here would be 30 degrees, or I can say pi over 6, which ties with 30 degrees. 2 pi over 6, which of course simplifies to pi over 3. Pi over 3. 3 pi over 6, which is pi over 2. 4 pi over 6, which just becomes 2 pi over 3. 5 pi over 6. 6 pi over 6. 7 pi over 6. 8 pi over 6, which is really just 4 pi over 3. 9 pi over 6. 10 pi over 6, which is 5 pi over 3. And 11 pi over 6. Okay. This guy's getting a little bit crazy, but if I just hone in on taking a look at this angle that's right here, this triangle that's created right here is a 30, 60, 90 right triangle. This is 30 degrees, pi over 6. This is a radius of 1, so in that 30, 60, 90 right triangle, if this is 1, this is half that. So this is going to be 1/2, and then this is x root 3, so this is 1/2 root 3, or root 3 over 2. So I can do the same thing and say, what are the x value and what is the y value, or what's the sine and the cosine here? So here, my ordered pair that's tied with that is going to be here. I can see that my x value is square root of 3 over 2, and my y value is going to be 1/2, because here, cosine, square root of 3 over 2 over 1, sine, opposite, 1/2 over 1. Okay, so this is the ordered pair that's tied with that location. Okay, I can move around. If I move up and I see this triangle, I'm going to erase these other ones so we don't get confused. Okay, if I take a look at this other triangle, at pi over 3, or 60 degrees, I see the exact same triangle created, but he's turned up on its side. So what I see here is this height now becomes, so this is 1/2, square root of 3 over 2. So the ordered pair that's tied with 60 degrees, or pi over 3, is now x value is 1/2, y value square root of 3 over 2. Okay, so I know this is looking a little bit messy right now, but I'm going to show you a slide in a second that's going to have all those values in it, and we'll talk about the positive and negative of each of those. Okay, so in the video that you just watched was a little crazy, but what we want to do is we want to try to go ahead and fill in on your handout all of the trigonometric, all of the unit circles. So in my radius of 1 here in my unit circle. Here I want to be able to fill all of these values in. So I'm going to start with you. I want to see if you can finish, and then I'll have it completed on the next slide. So here we know that this is, of course, this is, what do I want to put here? This is 0 degrees, this is 2 pi, this is 0 degrees, 0 radians, or 2 pi, 360, squeeze it in there, or 2 pi. And this is the ordered pair 1, 0. This is pi, or 180 degrees. Okay, and the point -1, 0. This up here is 0, 1. And here this is 90 degrees. And pi over 2. Okay. And then of course here 0, -1. And then here 270, or 3 pi over 2. Okay, so in the previous video I talked about right here finding all of these. These are the 45-degree angles, 45, 30, 60. Okay, and then we can create all of these values in our trigonometric circle by just going by sixths and then going by fourths. Okay, so take a second, take a look at what I did in the previous video, see if you can fill this out, and then I've got the solutions on the next slide. Okay, so when you work that out, we got this expression here. Here's my pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, etc. And then pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, etc. Notice the values that are going to go with each one of those. So remember that cosine of theta is equal to my x value, sine of theta is equal to my y value. So when I take a look here, this is related, of course, to this 30, 60, 90 triangle that's created in here. So here's my triangle. Okay. This length here is square root of 3 over 2, and then this radius is 1. So this is 1, half that value. So this is like 2x, x root 3. So square root of 3 over 2. Okay. Is that length right in here. Okay. So I'm just looking at 30, 60, 90 right triangle, and then notice right up here, those two are just going to be switched, because now I'm just taking that exact same triangle, but instead of that angle being 30, now that angle here would be 60 degrees. Okay. So I just want to think in my head here which one is longer. So in my lower 30-degree triangle, the long side, the triangle is kind of flat, so that long side is going to be associated with x, so square root of 3 over 2, and then when I have a 60-degree triangle, I see that that long side is associated with y, so I have 1/2 square root of 3 over 2. As I move around the circle, notice that I have those exact same ratios all the way around, but here I see that because x is negative in quadrant 2, I see that all my x values are negative. And then here in quadrant 3, I know that x is negative and y is negative, so both x and y are negative here. And then here, x is positive, y is negative, and so I see that reflected in all of these ordered pairs. Okay. Alright, moving on from there. Okay. Oh, I should also say, so what that means is that sine and cosine are positive in quadrant 1. They are, cosine is negative and sine is positive in quadrant 2. Cosine and sine are negative in quadrant 3. And then cosine is positive, sine is negative in quadrant 4. Okay, so let's take a look at what some of those values are going to be. So you saw this kind of expression here When r equals 1, obviously this is going to be equal to just y. So we said this before. This is going to be equal to y over 1. This is going to be be equal to x, and then y over x. Okay. The reciprocal functions, I can just flip those. 1 over y over x, and x over y. Okay, so let's take a look at what some of those values would be. So if I say here, what is the sine of pi over 6? Now remember, that's also asking what's sine of 30 degrees. Rather than putting that into a calculator, I'm just going to look here on my unit circle and say, okay, pi over 6, what is the y value that's associated with that? Okay. So notice here, pi over 6, sine is associated with the y value, so I'm looking here at 1/2, so sine of pi over 6 is just 1/2. Okay. Cosine of 2 pi over 3, so again I'm going to go over here, 2 pi over 3, so this is kind of like 4 pi over 6, come all the way over here to 120 degrees, and I'm going to ask cosine of 2 pi over 3. Well, cosine is associated with the x, so here I see negative 1/2. That negative means I'm in quadrant 2, that x is negative. Here I see tangent of pi over 2, so I'm going to come all the way up here. Pi over 2 is up here. Okay, I don't know what tangent is, but I know tangent is y divided by x, and so here I see y divided by x, 1 divided by 0, so I see that that is undefined. Okay. Down here I see cosine of 270 degrees, so 270 is right down here, the same as 3 pi over 2. Cosine is associated with the x value, so here I see that is 0. And then cosecant of pi over 6. So pi over 6 is right here, cosecant is 1 over sine. So if sine is 1/2, that means cosecant is 2 over 1 at that value. Okay, and I can answer any number of questions. This unit circle we should be able to reproduce for ourselves, but I should be able to feel confident being able to answer any type of question. So I might be able to say, something like sine of, whoops, that looks crazy, sine of 7 pi over 4. Okay, and anything that's a fourth we know is going to be that square root of 2 over 2, but I just want to determine which quadrant I'm in. Since sine over here is negative, it's going to be this guy right here, negative root 2 over 2. Okay. I could also ask something like tangent of 5 pi over 4. And I can see here tangent of 5 pi over 4 is y divided by x. I see negative square root of 2 over 2 over negative square root of 2 over 2. So I get out 1. Okay. Alright, so if we move down on our paper, you're going to see something that looks like this. And it says fill in the following chart, looking at the signs of what I would expect quadrant 1, 2, 3, and 4. And remember, this is going to be straightforward to use our unit circle to determine the signs of the functions in each of these quadrants. So for instance, here, sine, we know in quadrant 1, x and y are positive. So this is positive, and then I can say tangent is sine divided by cosine. So that's also going to be a positive value. In quadrant 2, x is negative. So here I know that sine is still positive, but x is negative. Tangent is sine divided by cosine, so that's a negative value. In quadrant 3, I see that both x and y are negative, so both sine and cosine are negative. But then a negative divided by a negative is a positive. And then in quadrant 4, x is positive, y is negative. So negative, positive, and then negative divided by a positive is a negative. Okay. We also have something called quadrantial angles. Quadrantial angles are those that lie on an axis. So it's a multiple of pi over 2 or 90 degrees. So we're going to find that those values are either undefined, 1, -1, or 0. Okay, because we're just going to look at kind of the radius of those circles, so these guys right in here. So for instance, sine of 180 degrees, notice I'm looking for the y value here, so this guy is going to be 0. Cosine of 0 degrees, so I'm looking for the x value right here at 0 degrees is 1. Tangent of 270, come all the way over here, we solved this guy before. It's y divided by x, -1 divided by 0 is undefined. Okay, so for cosecant of 90 degrees, we see that here sine is 1, so 1 over 1 would make cosecant of 91. Secant of 360, that's 1 over cosine. Cosine is 1 at that point, so this would also be 1. And cotangent of 180 would be sine divided by cosine, y divided by x, so that would be, tangent would be y divided by x. Cotangent is 1 divided by 0, so this would be undefined. Okay, so you can take a second, fill in the rest of these guys. Okay, you can work with your partner. Okay, and then take a look here. So this one, we've already done an example of that. I'll let you practice that piece. And remember making that reference angle for these guys. I just want to create that angle and then look at the triangle that's created between the x-axis and that terminal side, and then determine the reference angle of what remains here. So for instance, -pi/3, if I want to draw that angle here, I know that that's down here. Okay, so that is -pi/3, and I see that that is in fact also the reference angle in this case. Okay, and this would be the same or equivalent as saying -60 degrees. Okay, the reference angle for 7pi/6, so this is 6pi/6 and then 7pi/6. So this whole amount would be 7pi/6, but I see that my reference angle there is 1/6 past that pi mark, so I see that my reference angle theta prime is equal to pi/6, or 30 degrees. Okay, and then 230, that's 180 and then 50 more. So here, -230. So I see that my reference angle here is 50 degrees. Okay, jumping down, so I can do that here, draw the angle in center position, and then evaluate the trig function. Again, what I'm going to do is I'm going to draw that. If that's tied, that angle is tied to your unit circle, we're going to use that unit circle to be able to evaluate the exact value of those trigonometric functions. Okay, so I'll take 135, so that means here I'm 90 and then 45 past that. So we know that this is so that's 135. Here this is going to be a 45, 45, 90 triangle that's created in my circle. So here secant 1 over cosine, so I'm going to get square root of 2. Okay, because this point here, actually this is going to be negative square root of 2. Because here this point on your unit circle is square root of 2 over 2, negative square root of 2 over 2, square root of 2 over 2, and so 1 over that value is this. Okay, so I'll give you a second to try to figure these guys out. Then evaluate these trig functions. You want to just look or identify where this is on your trig function, and then use your x and your y's to be able to identify each of these. Okay, this last one just says find the other 5 trig values if I know that this is true. Based on what we did at the very beginning, I know that cosine of theta is -2 over 5. Okay, so I know that the adjacent side is 2 and the hypotenuse is 5. 5 was always positive, so that tells me that my adjacent side is -2. Let's see if I can sketch him. I'm going to sketch him right in here. So here, and it tells me it's between 180 and 360. So down here, cosine is negative in quadrant 2 and quadrant 3, but it tells me here it's between 180 and 360, so that in fact tells me that it's going to be quadrant 3. This here is -2. I don't know what y is, but here this is 5. Okay, so I can use Pythagorean theorem to be able to find this missing side here. So I have 4 squared, or -2 squared, 4 plus x squared is equal to 25. Okay, so I see that x is going to be equal to the square root of 21. And negative because I'm in quadrant 3. So then now I can create my 5 other trigonometric functions based on this triangle that I've created. Okay? Alright, and we've done kind of this piece before. So name the quadrant for which theta, sine of theta is greater than 0, cosine is less than 0. Okay, so you're just going to find those quadrants that are here. Okay? So again, this is quadrant 1, 2, 3, and 4. Okay. Best of luck walking through this. What I suggest is try your best, use each other as a resource, and we will touch base. We have a quiz in 2 class days from now, but make sure that you're posting questions on the homework forum, and if you're struggling, make sure to read the section 13.3 prior to starting your homework. Okay, thanks so much.